Okay, let's start. Today I am going to discuss special questions and theorem proof and one relation that deals with differentiation, polynomial function relation. Okay, first see this one. So in polynomial function, fx, if x minus a is a factor of fx, then fa equals 0. We call this is remainder theorem. That is called remainder theorem. If x minus a is a factor, then fa equals 0. Then here the special point, I haven't discussed this before. If x minus a square is a factor of fx, so here repeating linear factor, repeating factor. Then you say first one fa0, and second one f dash a also 0. Here for one linear factor fa0, here we have repeating linear factor 2 times repeated, then fa0 and f dash a 0. F dash means derivative, no? Then further if x minus a cube is a factor of fx, x minus a cube is a factor of fx, then first one fa0, second one f dash a 0, third one f double dash a 0, then second derivative also 0. This is very special theorem. So after 2019, we get this theorem. Repeated application here. X minus a square, repeating linear factor, then fa0, f dash a 0. X minus a cube is a factor, then fa0, f dash a 0, f double dash a 0. Very special relation. Okay. Now see that proof. First one, fx of x minus a pi x, then fx equal x minus a squared, x minus a pi x. Therefore fa 0, fa equal a minus a pi a 0. Then here second one, fx equal x minus a square times pi x. Now here factor x minus a square. Therefore by this one you directly say fa equal a minus a square pi a. It is 0. Then differentiate f dash x. Here derivative 2 into x minus a pi x plus x minus a square pi dash x. Here derivative. Then f dash a equal 2 times a minus a pi a minus a square pi dash a, that is 0. Then remember, for one factor fa0, repeating linear factor a0, f dash a, both 0. Okay. Then 3 times repeated one. See, third one. Fx equal x minus a cube f pi x. Then by this one you say fa0, a minus a cube pi a, it is 0. Then f dash a, differentiate 3 in f dash x, 3x minus a to the power 2 pi a pi x plus x minus a cube pi dash x. Now by this f dash a, here by this factor 3 into a minus a square pi a plus a minus a cube pi dash x pi dash a. Then 0, 0, we get 0 here. 0. Then further differentiate f double dash x 3 into, here derivative 2 into x minus a pi x 3 into x minus a square pi dash x plus here product 3 into x minus a squared pi dash x plus x minus a cube into pi double dash x. Now by this one, f double dash a, here 0, 0, 0, 0, 0. That is special relation. Okay. And remember, if x minus a is a factor of fx, fa 0. If x minus a square is a factor of fx, fa 0, f dash a 0, both 0. If x minus a cube is a factor of fx, say fa 0, f dash a 0, f double dash a 0. All three 0. That is very special relation. Okay, first write this one. First write that. First write that theorem. After that, you prove first two. You prove first two. Okay. Then do third proof. Okay. Now let's do one example. Let's do one question. So write this one. Write this one. Let a element of real set, simple a element of real set, and px, function px, be a polynomial of degree 4. Be a polynomial of degree 4. Write down degree 4. Show that x minus a is a factor of both px and p dash x, both px and p dash x, then x minus a square is a factor of px, where p dash x is the derivative of is the derivative of px with respect to x. With respect to x. Let fx equal x to the power 4 minus x cubed minus 6x squared plus 4x plus 8. Fx x to the power 4 minus x cubed minus 6x squared plus 4x plus 8 for x element of real set. Reduce that. X minus 2 squared is a factor of fx. Find the value. Find the value of f minus 1 and factorize. Factorize fx completely. Okay, you start it. Start it. I'll give you a few minutes. Start. Okay, let's see. Here show that x minus a is a factor of both fpx and p dash x, then x minus a square is a factor of px. Converse of previous one. Then if x minus a square is a factor of fx, then fa 0, f dash a 0. Now here it's converse. Then show that x minus a is a factor of both px and p dash x. Then we need to show that px has linear, repeat in linear one, x minus a square. X minus a square. Now let x minus a is a factor of px. Then pa equals 0, no? Pa 0. Here given data show that is a factor of x. Pa 0. Similarly, px x minus a pi x, no? X minus a pi x, let's say qx. If x minus a is a factor of px, then x minus a times qx. And because of this, we can say pa 0. Here pa equals 0. Then differentiate p dash x. X minus a q dash x plus 1 times qx. So here the derivative. Now since x minus a is a factor of p dash x, p dash a 0, no? P dash a 0. Therefore by this one you can directly write p dash a 0, no? Then p dash a minus a, q dash x, q dash a plus qa. Q dash a, qa. Now here p dash a 0, here this part 0, here 0, then here qa 0. QA 0. Then because of that we get QA 0. Then QA 0 mean here you can say therefore x minus a is a factor of x minus a. Is a factor of x minus a. Okay. Then here x minus a is a factor of px, similarly qx. X minus a is a factor of qx. Okay, now then you say x minus a is a factor of qx. Then qx equal x minus a times rx. Rx. Therefore, now previously here px. Here this is px now. Therefore, px equal x minus a qx, then x minus a qx equal x minus a rx. Rx. Then x minus a squared times rx. Therefore, you say x minus a square is a factor of px. Factor of px. Then you remember when x minus a is a factor of both px and p dash x, then there will be x minus a square factor for px. Okay, that's how we prove. Okay, complete that proof. Complete that proof. Okay, now here the question fx given, we need to show that x minus 2 square is a factor of fx. Then you need to show that f20 and f dash 20. Then you can say x minus 2 square is a factor. No? Apply the theorem now. Here fx given x to the power 4 minus x cube minus 6x squared 4x plus 8. Then f dash x 4x cube 3x square 12x plus 4. Then find f2. Find f2. 2 to the power 4, 2 cube, 6 into 2 squared, 4 into 2 plus 8. Simplify. 16, 8, 24, 8, 8. 0, 0. Then find f dash 2. 4 into 2 cube, 3 into 2 square, 12 into 2 plus 4. 32, 12, 24, 4. Here 36, 36. 36, 0. Therefore, here f dash f20 and f dash 20, therefore say x minus 2 square is a factor of fx. So we can apply that theorem. Okay. So therefore you can say x minus 2 square is a factor of fx. Find the value of f minus 1. Okay. Then fx given, then you find f minus 1. Then f minus 1 substitute minus 1 to the power 4 minus 1 cube 6 into minus 1 squared 4 into minus 1 plus 8. Here 1 plus 1 minus 6 minus 4 plus 8. Okay. 10 minus 2, 0. We get 0. Therefore, you say x plus 1 is a factor. So here biquadratic equation, biquadratic function. No? So biquadratic function, x minus 2 square is a factor, and also we have obtained x plus 1 is a factor. X plus 1 is a factor. Now we know 3 factors. No? We know 3 factors, then find the remaining factors. Find the remaining factor. Now just write fx equal x to the power 4 minus x cube minus 6x squared plus 4x plus 8. No? Then here we have identified x minus 2 square is a factor, and further x plus 1 is a factor. And here biquadratic, then further we have another linear factor. Here x to the power 4 coefficient 1, here 1, 1, 1, this will be 1. Here plus 4 need plus 8, put plus 2. Here plus 4 into 2 plus 8. Now here are the factors. So we have 3 linear factors, 3 different linear factors. One is repeated. One is repeated. No? Complete. Okay. Let's do another question. Let's do another question. Write with me. Write this. Let Px 2x cube plus ax squared plus bx minus 4, where a, b element of real set. It is given that x plus 2 is a factor of both px and p dash x, where p dash x is the derivative of px with respect to x. Find the value of a and b. For these values of a and b, completely factorize px minus 3p dash x. Okay, just start it. These are differentiation application of polynomials. Okay. times enough. Here x plus 2 is a factor of both px and p dash x. P minus 2, 0 and p dash minus 2, 0. Then substitute minus 2. 2 into minus 2 cube. Minus 2 is squared. B into minus 2. Minus 4, 0. Minus 16 plus 4a. Minus 2b minus 4, 0. 4a minus 2b 20. 2a minus b equal 10. Then p dash x, differentiate 6x squared 2ax plus b. 6 into minus 2 squared b 0. Then minus 4a plus b 24. Second one. Then simultaneous equation 1 plus 2. 1 plus 2. Then cancel b minus 2a. $34. Sorry, 44. No, 34. A equal minus 17. Check simplification. $24. Minus 24. Minus 24. Then 1 plus 2, 14. Minus 14. A equals 7. A equals 7. Okay. Then substitute here. By 1. 2 times 7 minus b 10. Then b value equal 4. 14, 4. So now we know a and b values. Find the values of a and b. For these values of a, b, completely factorize px. Now px, we have to factorize px minus 3p dash x. Then px, 2x cube plus a mean 7, 7x squared, b mean 4. Minus 4, 3p dash x mean, here this is p dash x now, 6x squared, a means 7, minus plus 14x, b mean 4. Now here, both px and p dash x has factor x plus 2. So if x plus 2 is a factor of px and p dash x, definitely x plus 2 square will be factor of px, no? Then here you say x plus 2 squared times another function, no? So now check with this. Here for minus 4 need put minus 1, 2x cube need here put 2x. Now here x cube 2x cube there, plus 4 times minus 1 minus 4 there. Then definitely all the others must be there. Then minus 3, here take 2 outside. Then here 3x squared plus 7x plus 2. Then definitely here we have x plus 2 factor. Then here 3x plus 1. Now here x plus 2 is a factor, common factor. Take it outside. X plus 2, 2x minus 1, 6 into 3x plus 1. Simplify. X plus 2, 2x square 4x plus 3x minus 2, 18x minus 6. Here 2x squared minus x 4x plus 3x minus 2. Here it is. Then x plus 2, 2x squared minus 15x plus 8 minus 8. x plus 2. Now here quadratic one, you factorize 2x, x8, 1 minus plus. Then x plus 2, 2x plus 1, x minus 8, other factors. Okay, complete. Okay, let's move to another question. You take this. Let a element of real set and px, write with me, px be a polynomial of degree 4. Degree 4. Show that if x minus a කලින් කරපු එකමයිනේ පොඩ්ඩක් ඉන්න. Now say this one. Now say this one. Fx divided by x minus a. Remainder we call fa, no? This is division algorithm. Now here I'm going to divide this fx by x minus a squared. X minus a squared. Need to find remainder. Then we know fx divided by x minus a squared. We have quotient pi x. We have remainder like px plus q, no? Linear remainder. Now here fx x minus a squared pi x px plus q. Now differentiate f dash x. Here 2 into x minus a pi x x minus a square pi dash x plus p only, plus p. Therefore, f dash a equal, here 0, 0, p. F dash a equal p. Then here by this, f a equal here 0, pa plus q. P into a plus q. Now P equal F dash A, then F dash A times A plus Q. Therefore now Q equal FA minus A F dash A. Therefore remainder Px plus Q. P mean F dash A x, Q mean FA minus AF dash A. Here the remainder. So fx divided by x minus a, directly we have remainder theorem. So when fx divided by x minus a square, repeating linear factor, so we have linear remainder. So we can obtain that using differentiation as well. So you get division algorithm, differentiate and substitute x equal a for both derivative and the function, then find that remainder. Okay, write that one. Here fx divided by x minus a, this is special one. Fx divided by x minus a square. Okay, similar way thereafter you try to find fx divided by x minus a cube. Find remainder when fx is divided by x minus a cube. Okay, let's write this one. Try to find this. Find the remainder when fx is divided by x minus a cube. Take time. Okay, see. Fx x minus a cube pi x plus r. Before that, let's write fx of x minus a cube pi x rx of x minus a cube. Then here cubic, then rx will be quadratic. Then you better write rx p times x minus a squared q times x minus a here p q here r1x. Okay, r1x quadratic. Now you better to get p times x minus a square q times x minus a r format. It is quadratic now. Then fx equal x minus a cube pi x p times x minus a squared. Don't mislead here, this is not a function. P times x minus a squared q times x minus a plus r. Okay, now you find r. Fa equal 0, 0, 0 r. Then differentiate f dash x 3 times x minus a square pi x here product no, x minus a cube pi dash x. Here p times 2 x minus a q times 1 are 0. Now f dash a 0 0 0 q. Now we know r value f a, q value f dash a, q value f dash a. Okay. Further you differentiate this. Further you differentiate f double dash x. Here 6 times x minus a pi x. 3 times x minus a squared pi dash x. Here this one product. Here this product 3 times x minus a squared pi dash x plus x minus a cube times pi double dash x, second derivative. And here 2p times x minus a derivative 0, q derivative 0. Here it is now. Then for this relation again you can substitute x equals a. Substitute x equals a. Then f double dash a 0, 0, 0, 0, 2p. 2p. Then p value equal f double dash a divided by 2. Then here p value, here q value, here r value. Then remainder r1x px squared qx plus r. Then p value f double dash a over 2, q value f dash a, x r value f a. That is the remainder. That's the remainder. Okay, do that proof. R1x, R1x. Remainder. Okay. Okay, you try this one. X to the power 4 plus 3x squared plus 2x minus 1 divided by x minus 1 to the power 3. Find remainder. Apply differentiation. Huh? Use differentiation. Okay, before that, see this one. Here, when we divide by x minus a cube, R1x will be quadratic relation. So, usually quadratic relation we can write ax squared plus bx plus c. This is okay, okay? Ax squared plus bx plus c. Remainder okay. But here we have x minus a cube term, x minus a factor. Here this quadratic same relation I wrote here p times x minus a square q times x minus a plus r. This also quadratic. Here also quadratic, this also quadratic. But ax squared plus bx plus c basic one. But when we write px minus a square qx minus a plus r, then we can easily find unknowns. That's why I wrote x minus a squared. So here this also quadratic relation, x minus a square quadratic. Therefore, same quadratic relation we can take now. Okay. You try that. Try to apply differentiation here. Take time. Here x to the power 4, 3x squared plus 2x minus 1 divided by x minus 1 cube. Write 5x, x minus 1 cube. Here remainder will be quadratic now. Then you can write p x squared qx plus r. Or otherwise you can write p times, here instead of this, you can write a times x minus 1 square, b times x minus 1 plus c. This is also possible. Okay. So here basic one, here customized one. So anyway, both are quadratic. Both are quadratic. Now I'll get this one, okay? I'll get this one. Then x to the power 4, 3x square plus 2x minus 1, x minus 1 cube, ix plus a into x minus 1 squared b into x minus 1 plus c. So here it is. Now you put x equal 1, 1 plus 3 plus 2 minus 1, 0, 0, 0, c. Then c value 5, c value 5. Then differentiate. 4x to the power 3, 6x squared plus 2. Here x minus 1 cube, pi dash x, 3x minus 1 squared, pi x, a into 2, x minus 1, b, c constant 0. Then substitute x equal 1 again. 4 plus 6 plus 2 here. 4 plus 6 plus 2, 0, 0, 0, b. Then b value 12. Then again differentiate. 12x cube squared, 12x, here 12x squared, 12x, here 3 times x minus 1 cube squared, pi dash x minus 1 cube, pi double dash x, 3 times 2 times x minus 1 pi x plus x minus 1 squared pi dash x plus 2a. Next derivative. Now x equal 1, 12, 12, 0, 0, 0, 0, 2a. Then a value 12. A value 12. Then a value 12, b value 12, c value 5. Okay. Front derivative 6x only, 6x only. Then this won't change. Here 6, 6x, 12, 6, a equal 9, a equal 9, a equal 9. Nah? Okay, then you write remainder. This is remainder now. Remainder a into x minus 1 square, b into x minus 1 plus c. A mean 9, x minus 1 square, b mean 12, c mean 5. You can expand x square minus 2x plus 1, 12x minus 1 plus 5. 9x square, 18, 12, 6. 9, 14, 2. 9x square minus 6x plus 2 is the remainder. Okay, when we are doing polynomials, we had another method, algebraic method. Here with calculus we can find remainder. Okay, with calculus we can find remainder. Or you can write pi x. So you can introduce pi x here, power 4, power 3, no? Then write pi x linear one. Then by equating coefficient also we can get. But this is differentiation application. That is differentiation application. Okay. Okay. Complete. Complete. Okay. Let's do another one question. X to the power 4, 5, 3x to the power 2, 4x minus 1. I'm going to divide here by x minus x plus 1 cube. Find remainder. Use calculus, use differentiation. Huh? Okay, try it. First write division algorithm. X to the power 5, 3x squared, 4x minus 1, identical, x plus 1 cube, pi x plus, write remainder, ax squared plus bx plus c. Here let's write general one, ax squared plus bx plus c. This is remainder. Okay. So we know customized version, but anyway, let's do this way. So you differentiate 5x to the power 4, 6x plus 4, here 3 into x minus 1 squared, 5x, x plus 1 cube, pi dash x, 2a, x plus b. Again you differentiate 20x to the power 3, 6, here 3 times, x plus 1 squared pi dash x, 2 times x plus 1 pi x, 3 times x plus 1 squared pi dash x, 3 x plus 1 cube pi double dash x, 2a. Now for this you put x equal minus 1, here minus 20 plus 6, 0 up to there 2a. Then a value minus 14 over 2 minus 7. A value minus 7. Then you go to previous step. Here 2, here 1. Okay. By 2, substitute minus 1, 5 minus 6 plus 4, 0, here minus 2a plus b, here 3, 9, 3, 2a minus 7 plus b, take b value, 14, 11, minus 11. Then by 1, take this, substitute minus 1 plus 3 minus 4 minus 1, 0, plus a minus b plus c. Okay. Then 3, 4 minus 1 minus 2 minus 3. Minus 3, a value minus 7, b value minus 11, c. Then c value 7, 11, 4, 6 minus 7. Remainder minus 7x square minus 11x minus 7. Remainder. So that means you have to differentiate twice at once. Thereafter you start substitution from second derivative. From the second derivative step you have to substitute. Then go previous step again and again. Then find ABC values. Okay, now let's move a little further. Let's do another question. So that is with differentiation, okay? Okay, you write this one. If y equals sin x over ex, y equals sin x over e to the power x, show that d squared y over dx square 2 dy over dx plus 2y 0 plus 2y 0. Okay, you just start. So that is differential equation. We have to differentiate the function twice to obtain the required relation. Take time. Okay. Now we better to cross multiply first. E to the power x y sin x. Now differentiate. E to the power x y derivative dy by dx. E to the power x derivative e to the power x times y sin derivative cos. Here first derivative. Again differentiate. E to the power x times dy over dx second derivative d squared by dx squared. E to the power x derivative e to the power x times dy over dx, here product. And for this product, e to the power x times y derivative dy over dx plus y times e to the power x derivative e to the power x cos derivative minus sin. Okay, e to the power x d squared by dx squared plus 2 e to the power x dy over dx plus y times e to the power x sin x equal e to the power xy. Now we can cancel e to the power x term. Then take y the other side. D squared by dx squared plus 2 dy over dx plus 2y 0. Here best technique. So division somewhat hard to differentiate. Division we have quotient rule, no? Therefore we better to cross multiply, then we can remove that division, no? Then product easier than division. So product derivative easier than division. Therefore cross multiply, differentiate twice. Again while differentiating you have to remove sin and e to the power x, no? So we know when we differentiate sin or cos twice we can reset it, no? So sin derivative cos derivative minus sin, we get same relation. Okay. Now further you try this differential equation. If y equals sin inverse x divided by 1 minus x square root, show that 1 minus x square d squared by dx squared minus 3x dy over dx minus y 0. Continue. Okay, here better to cross multiply. So I'm going to square this as well. Then differentiate. Here product 1 minus x square times y square derivative 2y times dy over dx plus y square times 1 minus x square derivative minus 2x y squared. Here 2 sin inverse x 1 over 1 minus x square root. Then sin inverse x over 1 sin inverse x over 1 minus x square root mean y, no? It is part y. Then 1 minus x squared 2 y dy over dx 2x y squared 2x y squared equal to y. Then you differentiate again. 2 1 minus x square times y. Before that cancel y, yeah? Just cancel y, then differentiate. Here 1 minus x square dy over dx second derivative d squared by dx squared. Here 1 minus x square derivative 2x times dy over dx x dy over dx y times 1 constant derivative 0. Constant derivative 0. Now cancel 2, then 1 minus x squared d squared by dx squared, 2x dy over dx, here minus 3x dy over dx, here minus y, 0. That's it. Okay. Then you try this. Prove sine rule by cosine rule. Prove sine rule by cosine rule, and also prove cosine rule by sine rule. Prove sine rule by cosine rule and cosine rule by sine rule. Continue. This is somewhat special proof. So when proving sine by cosine, you can take cosine rule directly. When you prove in cosine rule by sine rule, you can take sine rule directly. Okay. Now see, sine rule by cosine rule. So by cosine rule means you can take cosine rule directly. You can take cosine rule directly. See, cos A b square plus c square minus a squared over 2bc. Then we need to get sine A over A now. To convert cos into sine, square it first. Cos squared A b square plus c square minus a squared over 2bc squared. Then here 1 minus sine squared. B square plus c square minus a square to the power 2 for b square c square. Then subject sine squared. 1 minus b square plus c square minus a square to the power 2 for b square c square. Now this is sine squared. Now further you take sine squared over a squared. Sine squared a over a squared. Then get common denominator first. For b square c square minus b square plus c square minus a square to the power 2 over for b square c square, and further we have divided by a square, put a square here. Then simplify further. Then for a square, b square, c square. Okay, now expand for b square, c square. Expand this trinomial b to the power 4, c to the power 4, a to the power 4, 2b square, c square, 2c squared, a squared, 2a square, b squared. So when you simplify, you get a 2a square, b square, 2b square, c square, 2a square, c square, minus a to the power 4, minus b to the power 4, minus c to the power 4 over 4a square, b square, c square. This is it. So sine squared a over a squared. Sine squared a over a squared. So this is symmetrical type. This is symmetrical type. So similar you find sine squared b over b square, sine squared c over c square. You get same. Definitely you get same. Sine squared a over a square, it is 2a square b square plus 2b square c square, 2a square c square minus a to the power 4 minus b to the power 4 minus c to the power 4, 4a square b square c square. No? So similarly when you get sine squared b over b square, you get same. Therefore, similarly, Sin squared beta over b square equals sin square c over c square equal, write this here. Okay. Therefore, all of them are same. Then you say, therefore, sin squared a over a square equals sin squared b over b squared equals sin square c over c squared. Then sin a over a equals sin b over b equals sin c over c. That's how we prove sine rule by cosine rule. Sine rule by cosine rule. Okay, complete. This is very rare case, huh? Very rare case. Okay. Now see, cosine rule by sine rule, cosine rule by sine rule. Then you can take sine rule directly. So consider right side of cosine rule, that means b square plus c square minus a squared over 2bc. You take this. So if we can prove this on cos A, then that is cosine rule. No? Then by sine rule, we know sine rule. No? Sin A over A equals sin B over B equals sin C over C equal K. Here A equal sin A over K, B equal sin B over K, C equals sin C over K. No? You put that one here. So here right hand side of cosine rule. Then B mean sin B over K, sin C over K, sin A over K, 2 BC, sin B over K, sin C over K. Then cancel K square. Then here we have sin B, no? Sin squared B, here difference of two squares, sin C minus sin A, sin C plus sin A. Here sin square C minus sin squared A, right? Difference of two square and 2 sin B sin C. Okay. Then further you write sin squared B. Use CD, 2 sin minus sin, 2 cos C plus A over 2. Here CD, here CD. Then 2 cos theta, sin 2 theta. Then we get sin squared B, sin B plus sin C plus A into the other three, 2 sin C minus A over 2, cos C minus A over 2, sin C minus A. Divide by 2 sin B sin C. Then C minus A equal pi minus B. Sin pi minus B sin B. Two sin B sin C. Now cancel sin B term. Then numerator we have sin B. Sin C minus A. 2 sin C. Instead of B, you put pi minus A plus C. Then write sin A plus C. Sin C minus A. 2 sin C. Again use CD. Use CD. 2 sin C cos A over 2 sin C. Then cancel sin C, we get cos A. Cos A. That is cosine rule. Okay, that's enough for today.